Alright, good day student. As you can see, what we have today is you are required to find the derivative of e raised to power x raised to power 3 multiplying log in bracket 4x squared. So how do you find how can you differentiate this expression? So the first thing you have to do is to assign an independent variable. In this case, let y equals to e raised to power s raised to power 3 multiplying log what? Log 4s squared. So how do you solve it? Once you have assigned a variable, for easy way of solving it, you notice that this expression is a product rule. In this case, this is u and this can be our v, and by product rule you have that if y is equals to uv by product rule, then the derivative of y with respect to x is equals to u dv over dx plus what? V du over dx. So that is it basically. So that is it. Once you have done it, you can now go into solving it. How do we obtain the derivative of v with respect to x and the derivative of u with respect to x? So from here we can say since u is equals to e raised to power s raised to power 3, we can also assign another variable. We can say let z equals to what? S raised to power 3. So once you do that, this implies that u is equals to what? U is equals to e raised to power z, and for that reason du over dz will give us what? E raised to power z. That is a basic what? Basic derivative of exponent function. So when you differentiate a basic derivative of an exponent function, you still obtain the same function. So the next thing is to differentiate z, and since z is equals to s raised to power 3, is equals to s raised to power 3, so in this case the z over what? Dx will be equals to 3s what squared. Is it not? So from here, once you obtain it, this implies what? This means implies sign. This implies du over dx differentiating with respect differentiating the measure with respect to x will give us what? Dz over what? Dx multiplying what? Du over what? Dx dz. Am I correct? Yes. So once you do that, you will obtain this expression. So from these expressions you can now substitute the values of dz over dx. So dz over dx, du over dx is equals to what? Dz over dx, and that gives us 3s squared multiplying what? Du dz e raised to power z. So du over dx is equals to, we know that z from here is equals to s raised to power 3, so we have 3s squared e raised to power what? S raised to power 3. So this is the first thing you have to do. I can come here, we have obtained that du over dx is equals to 3s raised to power 2 e raised to power s raised to power 3. I can call this equation 1. So let's find dv dx. Basically you have to use what? The same method to do what? Find the same method to find what? Dv dx. So we say that v is equals to what? From our equation, we say that v is equals to log what? Log in bracket 4s squared. Also, v is equals to log 4s squared. So let us assign another value, internal value, because this is a chain rule. You do what? A chain rule. So let q equals to what? 4s squared. Is it not? Let q equals to what? 4s squared. Q is equals to 4s squared. So this implies that v is equals to what? Log q. So you need to convert log q to a natural logarithm, because this is equals to what? This is equals to log this. Mind you, this is log q to base 10. So let's convert it to natural logarithm. So this will give us log q to base e divided by log what? Log 10 to base e. So that is it. And this is equals to ln q over what? Ln 10. Ln q over what? Ln q over ln 10. We now have that v is equals to ln q over ln 10. So once we have converted to natural logarithm, we can now find the derivative. Alright, let's find the derivative of this function. We can find the derivative of this function also using product rule. This product rule, we got that v is equals to ln q over ln 10. Is it not? So we can split it into 2. This is the same as ln q multiplying 1 over ln 10. So using product rule, we can now have that dv over this can act as u1 and this one can act as v1. Is it not? So dv over dx, dv over dx is equals to, you keep this one ln q, you differentiate this. You know it's a constant. 1 over ln 10 can always give us a constant, and differentiation of a constant is equals to 0. Plus what? You keep this 1 over ln 10, you differentiate ln q. Hope you are seeing it. You differentiate ln q. If you differentiate ln q, it will give us 1 over q. So that dv over dx is equals to what? 1 over q ln what? Ln 10. So putting it in a bracket or leaving it the same, it is still the same. So dv dx is equals to 1 over q ln 10. Now we have gotten our dv dx. I can clean here. Can clean it and bring it to the. Have any question? So we have that dv over dx is equals to what? Dv dx is equals to 1 over, by mind the q is equals to, what do we say that is q? What do we assign to the q? We say that q is equals to 4s squared. Is it not? We said q is equals to 4s squared. See the original equation up here. V is equals to log 4s squared. So we assign internal value to the q, which is equals to 4s squared. So come here and replace it with 4s squared. So dv over dx is equals to 1 over 4s squared ln 10. So once we have arrived at this point, you can now Have any question? So in this case we have sorry, this is wait a bit. This derivative is with respect to q. Mind you, this is dv dq because that is the variable, not dv dx. This is dv what? dq. dv dq, sorry. So having gotten dv dq, we have to find what? Because I hope you are seeing it. From the original function, we say that v is equals to log what? 4s squared. And we say that let q be equals to 4s squared, so that v is equals to log what? Log q. And we arrive at what? Ln q over ln 10. Remember? So v is equals to ln q over ln 10. So we solve for dv dq and arrive at this. Is it not? So we have to differentiate q with respect to x. If q is equals to 4s squared, then dq over dx, dq over dx will be equal to what? 8s. That is it. I hope you are following. So now it is complete. We are find dv dq, and then we also find dq dx, so that when we differentiate this function with respect to s, that is dv over dx, we have what? dv over dq multiplying what? dq over dx. It is now complete. So that I can clean it here. I hope you are seeing it. So that dv over dx is equals to dv dq. dv dq is equals to 1 over 4s squared ln 10 multiplying dq dx 8x. So you can simplify it. If you simplify it, you have dv over dx. 8 cancel, 4 divide itself 1. 8 divided by 4 will give us 2. There is 2x here, so we have, let's say we have 2x over s squared. Mind you, this s squared you can write it twice. It is the same as x multiplying x ln what? Ln 10, so that s can cancel 1x. Is it not? So once it cancel it, you now have that 2 over what? X ln 10. So dv ds is equals to 2 over x ln 10. Any question? We have gotten equation 1. This is equation 1, and also this is equation 2. That's all we need to solve it. So once we have gotten the equation 1 and equation 2, and we say that y is equals to e raised to power what? S raised to power 3 multiplying log what? 4s raised to power 2. So before you continue, so once you arrive at this, we have equation 1 and equation 2, and then applying this product rule, we have that dy over dx is equals to u, and u is equals to, because say that this is u and this is v, and u is equals to e raised to power s raised to power 3 multiplying what? dv dx. dv dx is equals to 2 over s ln 10. 2 over what? S ln what? Ln 10. Using product rule, plus v is equals to what? Log 4x log what 4s squared. Multiplying what du dx, and du dx is equals to this value. So this multiplying what 3s squared dot what e raised to power x raised to power 3. Hope you are seeing it. So you can simplify it, simplify your work to get that dy dx, as we can now clean here to simplify, make it very easy for us. So in this case we have dy dx is equals to have 2 e raised to power s raised to power what 3 divided by x then what 10 plus what 3 s squared dot e raised to power s raised to power 3 log what log 4s squared. So this is the derivative of the given function. This is what the derivative of the given function, this function. So once we are given a function to derive, make sure you apply all the necessary internal and external, even it's a chain rule, product rule, to solve the given expression or equation, whatever they are given to you to solve. Find the derivative. So the derivative of e raised to power s raised to power 3 log 4s squared is equals to what 2 multiplying e raised to power s raised to power 3 divided by s ln 10 plus 3s squared e raised to power s raised to power 3 log 4s squared. So if you enjoyed this lesson, please click the subscribe button to encourage me for more videos for your view. Click the notification button whenever you have your new videos so that we notify you. Share and like. You can go to our website at www.manzananews.com/lesson_plan, or go to our website www.manzananews.com, register for monthly edition. You will see many videos, explanations, you see questions and answers that will help you do well in mathematics. If you enjoyed this lesson, please click the subscribe button before you go. See you in the next lesson. Bye for now.